So you're currently running a single Proxmox server and you really enjoy it, but you want to expand to a small cluster so your virtual machines have more room for activities. Do you add a second host as a standalone Proxmox instance, or do you cluster the two of them? Do you go for 3 nodes and build a full 3-node cluster? Do you need a QDevice? What even is a QDevice, and how do you install one if you need one? In this video, I'm going to cover tips and tricks specific to small Proxmox clusters of 2 or 3 nodes. I'm also going to go into how to install a QDevice on a Raspberry Pi, and whether or not you should have one at all. So here's the hardware we're working with for this video. These are my trio of Dell Wise 5060 thin clients that I used in the $100 Proxmox high availability video. Link up there for that video. Today we're going to configure them as a 2-node and as a 3-node cluster to show some of the differences in failover when using 2 versus 3 nodes. This is a Raspberry Pi. It's not a new one, it's a Raspberry Pi 2, and it's going to play the role of our QDevice, and we're going to see how that affects our 2 and our 3-node cluster stability. Since it's kind of hard to buy a Raspberry Pi, I'm going to show how to use this Dell Wise 3040 thin client, which is very cheap, as a sort of QDevice to help stabilize a 2-node cluster as well. So for our first example, we have 2 separate nodes, PVE1, PVE2. They're not clustered together. As you can see, we have a VM200 here, which is called Test Ubuntu 1, and we have another one on the other node that's also VM200 called Test Ubuntu 2. So we can have VMs with the same ID on each system because they're completely separate, they're not clustered together. We also have to log into each system independently to manage them. So both of these systems are up. I can go ahead and start this VM. It'll start successfully and turn green. There we go, it's running. Now if I go here and I disconnect it so it's not working anymore. So there we go, now we're unable to connect because the node is down. So if I go back over here to the first node and I say stop, I'm not going to have a problem because the 2 nodes are unrelated. Nothing they do affects each other. If we had a cluster, we would lose Quorum as soon as the second node is shut down. The first node would be unable to do anything. So now what happens if I want to migrate a VM from PVE1 to PVE2? Well, if we go here, convert it to a template, manage HA, none of those are good options. Yeah, we don't really have a good option here. There's no migrate button, because we can't do it. So if we want to move this VM from PVE1 to PVE2, we have to stop it. Then we have to go here to backup and do a backup. So we're going to send it to our shared storage on the NAS. It's only got a 6 gig disk because I only have 16 gigs to work with locally. Done. That was quick because it's so small. So now when we go over to PVE2, we have a different VM, but it had the same number, 200. And when I click backups, I can see that backup from the other VM 200 on the other Proxmox host. So you have to be careful that you don't mix up the numbers between the 2 systems. In this case, I could try to restore it, but because it has the same number, it's going to overwrite my 200 on the new system. So we should probably cluster these nodes to make managing them easier. But as long as we have VMs on both nodes, we can't cluster them. So we have to either delete this one or back it up and restore it under a different number later. So now that we only have VMs on one node, we can use it as the first node in the cluster. And then we can add other nodes to it. So we get the join information. Go over to PVE2, join a cluster, add the root password, go. So now it's going to appear that this never finishes, but we just have to refresh because it's going to get a new self-signed certificate. Accept the new certificate, and now we have a cluster, PVE1, PVE2, and we have our one VM that we kept because we deleted the other one. So now, from now on, the cluster is going to guarantee that all VM numbers are unique across the cluster. So now that we have a cluster, what happens if we lose one node? So we only have 2 nodes, so if we go to Data Center, HA, we say our quorum is okay. So we have number of nodes 2, each one has 1 vote. So if we shut down the second one over here, so now we shut down the second node, the second node is unavailable. We still have 2 nodes. Now we have no quorum on node PVE1. So if I try to start up this VM here, it says cluster not ready, no quorum. So we can't start the VM on PVE1, even though PVE1 is fine, because it can't be sure that the cluster state is going to stay coherent if it does a start a VM. So because we only have two, anytime we lose either one, we effectively lose both of them. So from the perspective of PVE1, it can't communicate with PVE2, but it doesn't know what's wrong. Maybe PVE1 lost its network connection and PVE2 is running just fine. So if PVE1 goes and changes settings, PVE2 won't know about that and they'll have to synchronize them later. Or maybe PVE2 is actually dead and PVE1 should do something about it, but it can't tell. So without something that can corroborate which node is actually dead or which node is actually having problems, the cluster can never really be stable with just two nodes and nothing else. So we have three options on where to go from here. Our first option is to give one of these nodes an extra vote. So we can see here each node has one vote. We need 2 votes to maintain quorum. So if we give PVE1 a second vote, then PVE1 can operate on its own because it would need 2 out of 3 votes in that case. And if PVE2 were to shut down, PVE1 would be fine. But the inverse would not be true. If we were to lose PVE1, PVE2 would not be able to operate. So this does not give you high availability. It's pretty easy to set up though. So we just have to go to PVE1. So I booted back up PVE2. So PVE2 and PVE1 are both running. So now we can make a change to make PVE1 have an extra vote. So we're going to edit etc PVE quorusync.conf. And so we just go down to here, quorum votes 2. And we also need to edit the config version to increment it by 1. So it's currently 2, we're going to make it 3. We're going to save this. Make sure you don't save if you're in the middle of editing the file. Make sure you only save when you're all the way done and all of the changes are correct. Otherwise, you could end up with a bad configuration file, and QoruSync would be very angry. So now that we've done that, QoruSync should reload itself. We go back here. We see suddenly we have 2 votes. Now PVE2 is shut down, so I should still be able to start VM200. And it looks like it was successful. There it goes, starting. So quorum is still okay. All is good. So our second approach is to add a third node. And if you're adding an x86 based node, it's easiest just to add a full Proxmox install instead of adding a QDevice. So I'm going to do that here. So I got this Dell Wise 3040 thin client that I set up to run Proxmox. It only has 2 gigs of RAM and 16 gigs of eMMC, but this will be just fine as a third node. We don't have to run any VMs on this. Or if you use containers, you could run some really small containers on here. But we're going to configure this as a third node to balance the cluster. So here we have PVE 3040, a little tiny 3040. It's got a tiny CPU and it's using half its RAM, just running Proxmox. That's not a good sign. But we're going to add it to our cluster. So copy the join information. And then refresh again because it'll get a new certificate. Yep, so it got a new certificate because we added it to the cluster. We continue, we log in, and we're good. So because this node is too small to really run VMs, we should prevent our VMs from actually running on this third node because we're using it effectively as a QDevice without having a QDevice. So to prevent HA services from being migrated around onto our third node, because our third node is just there to maintain quorum, we're going to create a group that contains PVE1 and PVE2 called the HA group. So now that I've created that group in the HA system, when I go to manage HA, I can pick the HA group and it'll only allow PVE1 or PVE2 to run this VM. Set that to started. And now it should start up the VM automatically. So if we were to put this VM on shared storage, such as a NAS, we wouldn't have to do anything special. But if you don't have a NAS, or you really want high availability storage without using a cluster file system, your other option is to replicate. So I go to this VM and I say replication. I can add a replication job. So target is PVE2 and we say every 15 minutes. That's the default. And what that'll do is that'll copy the disk from PVE1 to PVE2 so that there's always a copy of the disk on both systems. And that way, if it ever has to migrate from PVE1 to PVE2, at worst, it's lost 15 minutes of data. Now, if you have more than 2 nodes in your cluster, you have to add all of them here. So if PVE 3040 were capable of running this VM and not excluded by the pool rule, then we would have to copy it to all of them as well. And this also means you're using disk space on all of your nodes for all of your high availability VMs. So say this was Home Assistant and it's only maybe 10 or 15 gigs. That might not be too bad to have a copy of it on every system. But if this is a larger thing, say your security NVR or something like that, you might not want to keep 3 copies of it everywhere. But if you don't have shared storage or your high availability requirements require you to have highly available storage, then you have to duplicate the drives to all of the nodes. Your other option is to use a cluster file system like Ceph, and stay tuned for the next video on that. So we can see here replication was successful. That means that we should have a copy of VM200 on PVE2, which we do, but there's no VM200 on PVE2 yet because it didn't migrate. We could force it to migrate, or we could kick PVE1 offline and see if it can migrate itself automatically. So PVE1 lost power, so now it's offline. It still thinks that VM200 could be running, but we're not really sure. We click on HA, so Quorum is still okay, so the cluster can still operate. So now it's fenced the VM. That means it's given it enough time that it's pretty sure PVE1 is actually dead, and it's ready to try to migrate it. So now it's decided to start the VM on PVE2. And because we don't have shared storage set up for this VM, it had to use the replicated copy, which could be up to 15 minutes old. But our high availability service is now running again, and it only took us a few minutes to get it switched over. So with only a few minutes of downtime. Not too bad. So, if you do want to use a QDevice, let's set one up on a Raspberry Pi. So we're going to choose Raspberry Pi OS Lite, unless you want to use a desktop, you don't need to. I got a 16 gig SD card. We're going to click the little thing here, set the host name. We're going to enable SSH, and it requires us to set a password for the Pi. I'm not going to configure Wi-Fi because I'm using wired Ethernet. And let's go. Now we let this run. Okay, let's get this SD card into the Pi and get it booted up. So now we're on the Pi. We've logged in over SSH. So now we need to do a couple things. So in order to provision the QDevice in our Proxmox cluster, Proxmox wants to log in to the Pi as root to do some configuration. So we need to set the password for the root account and then enable SSH login as root. So the new password for root. So now root has a password. Now we need to let them log in. So we need to edit etc ssh sshd config. Forgot to use sudo. So sudo nano etc sshd config. Permit root login is the line we're looking for. So we need to uncomment it. By default it says prohibit password, which would mean that if we enabled this, root would only be allowed to log in with an SSH key instead of with a password. So we're going to set this to yes. That means that root can log in with a password. Not the most secure thing to do, but we can revert it back when we're done by changing this back and commenting that line out. So now we need to restart SSHD. And that should allow Proxmox to log in as root. We can also start installing the CoreSync, QNet, and QDevice packages. So we're going to do sudo apt update and upgrade like we love to. And then we wait for apps to update and apt to upgrade. Raspberry Pi is not the fastest device ever built, so it'll take a while. So now we need to install CoreSync QNetD, CoreSync QNetD, and CoreSync QDevice. Yes. Okay. Now we're done with the Raspberry Pi. We move back over to our Proxmox cluster. So we're back at the 2-node cluster we set up earlier, before we added the 3rd node. So on Proxmox, we also need to add support for the QDevice, and we do that by running apt install CoreSync QDevice. And we need to do that on both PVE1 and PVE2. So now from either one, we need to provision the QDevice from the Proxmox system. So to do that, we call pvecm QDevice setup. Then we give it the IP address, not the DNS name of the Raspberry Pi. And then -f. And -f will force it to overwrite any settings that are already there, just in case. So we need to trust the fingerprint, yes. We need to give it the root password of the Raspberry Pi that we just set up. We let it do its thing. It's going to reconfigure CoreSync, and then all should be good. So now we notice that the new node does not show up here as a node in Proxmox, because it's not a Proxmox node, it's just CoreSync. We still only see that we have 2 nodes, and the cluster is Core 8. So again here, we only have 2 nodes. We still have Quorum. So what happens if we shut down PVE2? So with only 1 node remaining in the cluster, if we don't have the QDevice, we should lose Quorum. So PVE2 is now shut down, and we have 1 node, but we're still Core 8, and that's because the QDevice is there to provide a vote. So here on the HA screen, we can see the master is now PVE1. So because PVE2 is dead, the QDevice is saying, I can talk to PVE1, but I can't talk to PVE2. So I'm going to vote for PVE1 to be the master because I believe it is still healthy. And that allows PVE1 to be a sole master by itself because the QDevice is there to prop it up with votes. So again, like the situation where we had 3 Proxmox nodes, but 1 was only used for Quorum, we can still migrate between these 2 nodes. We still have to replicate this node using replication. We don't get away from that with the QDevice. The only thing the QDevice gets us is to not have to install Proxmox on the 3rd node that's only for voting. So the only reason you would really use a QDevice is if you're using a device that can't run Proxmox natively, or you want to run it in a container on your NAS or some other weird thing like that. So now we're going to bring in a 3rd full node to the cluster. So we have PVE3, which is our 3rd little thin client. So we're going to join this to the other 2, get the join information. So again, because we joined the cluster, we got a new self-signed certificate. And we log in again. So now we have a full 3-node cluster. All 3 of the nodes are full nodes. They're capable of running any of our VMs. So now we don't need to add a mini node or a QDevice. We can just let all 3 nodes share the load between all the high availability VMs. We don't need to set up an HA pool because all of the nodes by default are part of the pool. If we want this node to become HA, we can say manage HA. Don't give it a group. And it'll use all of the nodes. Say add. And go ahead and start. So what happens if we were to add a QDevice even though we already have 3 nodes and we don't need them? Could the QDevice help us here? So we're going to install QDevice again on all 3 nodes. Now we're going to add the QDevice. Okay, so now it's done. Now if we're in PVECM status, This will give us a bit more information. So now it says we have 5 votes total in the system because the QDevice is providing 2 votes. So the quorum is 3. That means that if we were to lose the QDevice, we would not be able to sustain another failure in the cluster. And this is by design. Proxmox only intends you to use a QDevice when you have an even number of nodes. If you have an odd number of nodes, it will intentionally give extra votes to the QDevice. So having a QDevice in a 3-node cluster, which is already stable on its own, can only hurt stability, because now you can't afford to lose the QDevice and another device. With an even number of nodes, the QDevice will always get 1 vote. So having the QDevice can only help support the cluster stability, because with the QDevice you can afford to lose any device in the system, whether it's the QDevice or a regular node, and the cluster will still operate. So what have we learned today? Well, if you have a 2-node Proxmox cluster, you probably want to do something to keep the cluster stable if you lose 1 node. You could add a QDevice on a Raspberry Pi, or you can add a 3rd small node and don't allow it to join the HA pool. Either of these solutions keep the cluster quorate if you lose any single node. If you have a 3-node cluster where all 3 nodes are running VMs and containers, you should not add a QDevice. Adding a QDevice to a 3-node cluster makes the cluster unable to sustain a failure greater than the QDevice itself. So you can lose any one regular node and still be fine, but if you lose the QDevice, you now can't lose any of the other nodes also. So effectively, you're worse off than just having the 3 nodes by themselves, where you can lose any one node and be fine. We also touched a bit on the replication requirements for small clusters. One option is to use shared storage, so all of the nodes have access to all of the VM disks. But this creates a single point of failure at the network storage. The other option is to use local ZFS storage and replicate the VM disks across all nodes in the cluster. If you use local LVM storage, that's just not an option for high availability. So replicating with ZFS might work well for high availability, and it prevents you from having a single point of failure on the network storage. But it does take up quite a bit of space, especially if you have large VM disks that you don't really want to be duplicated 3 times. Stay tuned for the next part of this series where I hyper-converge this cluster using these 128 gig flash drives. We're going to give every node its own storage, share the storage across the whole cluster in a way that keeps high availability resources replicated, but doesn't triplicate all of our data. Thanks for watching. Bye.